technical debt, why it will ruin your software. As we can see here, this picture, it is a very known monument and it's located in Italy, more specifically in Pisa, and it's called Leaning Tower of Pisa or just Pisa Tower. This building has a very interesting story behind it. It was built on the 12th century, and due to soft ground issues which could not sustain its weight, the tower started to lean. The structure was stabilized in 2001 after 8 years of rework. In fact, one of those issue fixes made the landing worse. And I mean, who here never did a refactoring that turned the problem worse, right? I can blame them. And now you may have two questions in mind. First, maybe you are wondering why the Pisa Tower relates to technical debt. And second, am I Italian? My accent and my last names are Italian. For the first one, you will find out till the end of this talk. And about the second one, no, I am not Italian. Actually, I'm from a distant place from Italy. I am from a city called Recife. And you are hearing a Portuguese accent because I am from Brazil. And Recife is the city that has the best carnival in the world. And at least two people here will agree with me, because besides me, Mariana and Dani, that are giving talks in this conference, are also from Recife. My name is Luan Fonseca. I am working with Django since the version 1.2, almost 10 years already, and I'm the founder of an open source project called speakerfight.com, which is a call for paper platform that is responsible for a lot of meetups and conferences back in Brazil. And also I'm a software engineer at LabCodes. LabCodes is a software studio based in Brazil, and we specialize in creating custom web products fitted for specific needs. And we believe that software should be built by fulfilling clients and user expectations. Our software is always aimed at solving problems and optimizing processes. It's an incredible honor for me to be part of this conference giving talks, because last year I was just attending. So, okay, the agenda of this talk will start with a short story about John, showing the reality of an everyday programmer. Then we will find out why technical debt is seen as a bad thing, and who should be responsible for that. And after that, we'll go through some solutions that are not so good solutions, but and check some healthier solutions for this problem. And we will discuss if it's lucrative for the companies to take care of technical debt and what Ward Cunningham meant by this concept. And based on all that, we'll talk about what is beyond just profit. Okay, John the programmer. This is John. John is a senior software developer, always with a ton of work to do. John is a 5-star programmer with years and years with expertise in Django. Suddenly, a new project appears on John's desk, and this new project needs to have a payment system, social authentication, and the integration with our third-party shipping service. The due date for all that is just 1 month. As John is an awesome employee, which always delivers his tasks, he went there, took the project, and delivered in time. After that, when the rest of his team went to review his code, they found that John's code had some issues, like inconsistent payment bugs. Sometimes the shipments were not being processed, and the authentication were too naive when checking social accounts. John knew that his code had some problems, but when John was close to the due date, another project was scheduled to him, and then he didn't have time to fix those problems. We had to deliver the project the way it was, But John is positive and kept thinking, in the future, I will come back and fix everything. We all know that this won't happen, right? After the review, the team found some problems on his code, like the code responsible for the payments on his app was not flexible enough to accept different currencies. If the shipping services is down for any reason, the delivery could not happen, and also users with deactivated accounts could sign up on his application. Besides all that, the code didn't have any automated tests. And that's what we call technical debt. Why is that? Because as he chose a first-time solution, because of the delivery date, the code had some problems, and the team accepted that. In the future, if the business logic changes, the cost of changing John's code will be higher. And this is the moment when the technical debt was introduced on John's software. What happened to the Pizza Tower is closer to what we understand of technical debt. It started with a few problems, and suddenly those problems escalated so quickly that past some time, it will fall down. The same happens with our software. With us, that usually happens and is more visible during the process. Because after some time, it starts to be harder and slower to deliver new things like features or bug fixes. And we are used to think that have some level of technical debt in our software is a bad thing. I mean, usually it is. But we can see it as an strategic move, and if we could have some business advantage on delivering something really quickly, it's awesome for our product. The major issue on that starts when we forget about what we did. And accepting that is a trade-off. We can move fast and pay the consequences for that decisions later. It's really a common thing to do, but remember that costs increases over time. So if you identify yourself in any of those situations, it's really okay as soon as we have some on our backlog, some dedicated time to decrease it. And that's a really common scenario on delivering new things. If we look at Martin Fowler technical debt quadrant, we can easily find that John is on the top part between being reckless and prudent. He knew that he didn't have that much time for designing the best suitable solution, but also addressed that in the future he will need to come back and improve his code. When we pay attention to the name technical debt, we are guided to think that it's a developer's team issue just because they were responsible for creating that code. The problem is software is a result of the entire company structures and processes. Also, the entire software industry have changed so much from the time that technical debt term was born. As in John's scenario, the problem of the not so good code that he wrote is more like a management or product team issue than his. Because we know that John is a good developer, but he needed to be deliberated over the problems in order to deliver what he was asked to. Sometimes the bottlenecks that are generating debt comes from different parts of our software. And like management team may not be up to date with the developer's velocity. The product team might not have a big picture plan to share with the developers, or even the UI UX team may be too far from the dev team, and they could be causing rework or maybe creating some unfeasible interfaces and experience to be developed. We also can't forget that sometimes we need to blame ourselves for bad decisions, like choosing a high-patch framework or stop giving attention to designs on a dying framework or a deprecated one. All of this is our responsibility. Or even if the developers are not testing the application as it should be. Okay, after defining what problems we can have on our applications, we need to see that what are the possible tools that can help us deal with those situations. Imagine that if they stopped working on the Pisa Tower and bring everything down to rebuild it, the chance that the same mistakes or even new one appears on the tower is really huge. Not even think on the amount of money spent on destroying and rebuilding. In the Pisa Tower, we could be like just postponing the problem by adding more people to work on pulling the other side. And in your software, by adding more people to the team, you have now one problem that you need to deal with the existing issues on your code and also explaining the context to these new people. And it's more time consuming than we think. What happened on the Pisa Tower was exactly that. As the tower was leaning, they decided to stop tourism until it was fixed. But in our scenario, it could be like really nice to stop everything and fix everything and all that. But it's also a real challenge to convince everyone that it will be like 3 months, 4 months without delivering things or fixing bugs. And also, if you just stop everything and fix the depth points that you have found, after some time you need that again because your code will grow again and the new depth points will merge. And also, if we just create a new board for the new technical debt problems, after some time, it may be invisible for the team. Like, if a full backlog on our sprints is already invisible enough, imagine a separated one. However, those are the solutions that most people go for it. Okay, Luan, if those options are not the most feasible solutions, what can we do? Okay, based on everything we see, we need to come up with a few feasible solutions for dealing with technical debt. The impact is a process of identify, mark, plan, act, and test on technical debt problems. As it says, the first is all about finding it. Then the second one, we need to make sure that those candidates are visible for the team by creating tasks on a board and mark them as a technical debt issues. And we should also set a priority on those tasks based on their relevance. And tools like Jira have mechanisms to increase that priority over time, which is awesome because, as we've seen before, the cost of technical debt increases over time. And based on those market tasks, we need to stick to a plan in order to work on those and really follow that plan. And after that, we should act on decreasing the debt. And the most important part in this is to test everything that we did to make sure that we didn't break any behavior on our software. I got that from a book called Refactoring for Software Design, Managing Technical Debt. Okay, if you don't know how many tasks you should put on your backlog, we could use like the Pareto principle, where 20% of the team productivity is assigned to those technical tasks, and the 80% can be used on normal tasks like features, bugs, and everything else. And if your process have some big releases after some sprints, we could schedule a meeting to discuss everything that was introduced on our code and also that everything that has potential to become that technical debt issues. By doing that, we increase and identify those candidates earlier. And those are three examples of possible solutions, but I highly recommend you to be critique about everything and see what best suits you. Okay, let's dig deep on an economical view of the cost of working and dealing with a system that has some level of technical debt. There is this talk of J.B. Heisenberg that he explains the cost of the next new feature of your software and how can you decrease the uncertainty of that cost. In this chart, he does a comparison on those two costs. And as we can see, the growth of the growth of the cost on a software that were built without thinking on design, on good practicing, on refactoring, grows quicker than if you start to do your software thinking on design. Even if the design first software has a higher cost at the beginning, we can see that this cost is being mitigated over time when compared to the other approach. And over time, the cost of the next feature without thinking on design will become higher than you write everything from scratch. And if you are writing your software without thinking on design, you are betting that your software will stop working before that dashed line moment. And the hardest part on this is because we just don't know when that moment will happen. It can be in 1 month, 3 months, 1 year, 10 years. We just don't know. Okay, poor quality software has become one of the most expensive topics in human history. In 2018, CISQ released an report on US software costs, which was calculated considering legacy systems, massive failures, and the cost of trouble and concealed projects. Just a notion, this amount corresponds to two-thirds of the total expenses on human health in the same year for US. And programmers spend an average of 3.8 hours a day on debugging bad or low quality code. So imagine all that money being used on other things like better wages, social initiatives, training, and personal improvements. Okay, Ward Cunningham created the technical debt concept in 1992 using a financial metaphor to explain for non-tech people the implied cost of additional work on a code. Everything that we know as good practices on software development nowadays, Ward is responsible for a lot of them. And as Ward says on the definition of that metaphor, even if we have a great code with the best practices applied, that doesn't mean that we have a low technical debt. Okay, if the code isn't aligned with the domain of our product, we will always be on a technical debt because we will continue to grow our code without thinking about the best solution for our domain. And also, not adding back the knowledge that we gain over time to that software will also increase the technical debt. Okay, and besides saving money and delivering things fast, there are several things that we can identify as a points of trouble on our life caused by working with a high level of technical debt. Who here already had or still have some code running on something outdated or not maintainable anymore? It's a really common scenario for us. And it's really hard to deal with because we need to accept the consequences of and the issues that come along with that. Usually, you start to copy and paste codes from an outdated library or framework and fix on your own, or even sometimes we just fork it and use our own versions. Besides that, we could face some compatibility issues with new stuff, like some platform as a service that you want to use, but you can because you are stuck with that deprecated framework. And also imagine how hard could be for someone to be reallocated in the market after working like for 5, 7 years in some Python web framework that's not maintained anymore. And then they move to a new career as a Django developer. A lot of concepts and tools that we are used to work with may don't even exist in that outdated library. Technical debt brings a lot of weight to our lives. Because if you are consistently dealing with bad code, a task look like that looks like really easy to fix can become a monster. Even more, if you are new to the project, it's really common to become afraid of doing changes. And also the planning meetings can become endless because the dev team needs to work with the project managers to explain how hard it is to deliver things now. We also start to get anxious because we don't know if something will come up in the middle of the sprint or some big failure or a hard to find bug. And also doesn't make sense to your software company to grow like 300% each year if your team doesn't have mental health and time to work on that scale. It's a really common scenario for startups to glamorize excessive working hours because there were some high peak of sales or some application that brought everything down in the middle of the night. In a realistic and respectful area, the machines could take that care of those hard situations instead of putting all the pressure on us. And okay, the pizza tower is now sustainable, and this is one of the rare situations where a bug becomes a feature, and it will not fall anymore, even though it's still leaning, but in a controlled way. And I'm pretty sure that's not because all of those theories trying to push it back. And the same can happen with John's software. If we apply all of those feasible solutions, we can have the same scenario of a sustainable software. Okay, all the references for this talk are saved on an awesome list on LabCode's GitHub page, and you can just go to lab.codes-tech. My God, tech debt, and you found out like all the references that we need that we have here. And obrigado, and that's it. Oh my God, I'm so. Okay, all the references for this talk are saved on an awesome list on LabCode's GitHub page, and you can just go to lab.codes-tech. My God, tech debt, and you found out like all the references that we need that we have here. And obrigado, and that's it.